Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of m minus 2 to the power of m is equal to 65. And we want to find the value of m. So now for our solution here, we're going to start with our equation, 3 to the power of m minus 2 to the power of m is equal to 65. And now 3 to the power of m, this is the same thing as 3 to the power of m to the power of 2 over 2. Minus now 2 to the power of m, this is the same thing as 2 to the power of m to the power of 2 over 2. And 2 over 2, that's the same thing as 1. So it's the same thing as 3 to the power of m to the power of 1, which is the same thing as 3 to the power of m. Same thing for 2 to the power of m. 2 over 2 is 1, so this is the same thing as 2 to the power of m to the power of 1, which is the same thing as simply just 2 to the power of m. So now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of m to the power of 2 over 2, this would equal 3 to the power of m times 2 over 2 minus 2 to the power of m to the power of 2 over 2 is equal to 65. Now, m times 2 over 2, that is equal to 2m over 2. So I have this minus 2 to the power of m to the power of 2 over 2 is equal to 65. Now, this is the same thing with 2 to the power of m to the power of 2 over 2. I have 2 to the power of 2m over 2, or this is actually m times 2 over 2. And then now 3 to the power of 2m over 2 minus 2, m times 2 over 2, which is 2m over 2, is equal to 65. Now remember, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n, right? And m and n here, these two are interchangeable, meaning m times n, this can also equal a to the power of n times m, because for multiplication, order doesn't matter. So meaning, if these two are the same, that means that this is also equal to a to the power of n to the power of m, right? Meaning a to the power of m to the power of n is equal to a to the power of n to the power of m. So right here, I have m times 2 over 2, so we could actually rewrite this as 3 to the power of m over 2 to the power of 2 minus 2 to the power of m over 2 to the power of 2 is equal to 65. Now what I'm going to do is I'm going to let the variable x equal 3 to the power of m over 2. And I'm also going to let the variable y equal 2 to the power of m over 2. Okay, so now that we have that, now if I substitute in x for 3 to the power of m over 2 and y for 2 to the power of m over 2, I get x squared minus y squared is equal to 65. Now, if I have something in the form a squared minus b squared, this is actually equal to a plus b times a minus b. And this is actually a very important property of algebra. So for x squared minus y squared, this is obviously equal to x plus y times x minus y, which is equal to 65. Now 65, this is equal to 13 times 5, right? So now, because we have x plus y times x minus y is equal to 13 times 5, we can think of x plus y as 13 and x minus y as 5. So this is essentially 13 times 5 is equal to 13 times 5. Meaning we could say that x plus y here, this is equal to 13. And we can also say that x minus y, this is equal to 5. So now here we have a system of equations. As you can see, we have two equations. This is equation 1, this is equation 2. And we want to find the values of both x and y. So to do this, we are going to add both of these equations. So if I add these equations, first off, x plus x, that's 2x. Y minus y, these two cancel out, so I get plus 0 is equal to 13 plus 5 is 18. So this means 2x is equal to 18. And now if I divide both sides by 2, these two cancel out, and I get x is equal to 9. So now if x equals 9, I have to plug x into the system of equations to solve for y. So our original system of equations was x plus y is equal to 13 and x minus y is equal to 5. So if x is equal to 9, then I'm going to start by plugging in x for 9 into our first equation, x plus 9 equals 13. So if I do that, I get 9 plus y is equal to 13. And now I can simply subtract 9 on both sides to get y is equal to 4, because 13 minus 9 is 4. Now for x minus y is equal to 5, I'm going to plug in both values and check. So now I have x, which is 9, plus y, which is 4, or sorry, minus, this should be minus 4 is equal to 5, and 9 minus 4 is indeed 5, so I get 5 equals 5, so the values of x and y are true. So now, remember how we set x equal to 3 to the power of m over 2, and we set y equals 2 to the power of m over 2. So now x, remember this is equal to 9 and y is equal to 5. Or sorry, y is equal to 4. So now I have 9 is equal to 3 to the power of m over 2. And 9 here, this is the same thing as 3 squared, so I get 3 squared is equal to 3 to the power of m over 2, meaning 2 is equal to m over 2, and m is equal to 4. Now let's check with the other one. We have 4 is equal to 2 to the power of m over 2. 4 is 2 squared, so 2 squared is equal to 2 to the power of m over 2, meaning 2 is equal to m over 2, and 4 is equal to m once again. So the value of m here is 4. Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of x equals x. Now what I'm first going to do is I'm going to divide by x on both sides. So we have x to the power of x equals x, and if I divide by x on both sides, well, first off, on the right side, x divided by x, well, that's simply 1, because anything divided by itself is 1. Now on the left-hand side, we have x to the power of x divided by x, and x here, our denominator, this can be written as x to the power of 1. And if you guys recall an important property of exponents, it states that a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So this is the formula for dividing exponents. So right here we have x to the power of x divided by x to the power of 1. And x in this case is a, x is m, and 1 is n. So if we put our variables into this form, we get x to the power of x minus 1. So now we're actually going to rewrite this as another, actually before I rewrite this, another important property of exponents is that if we have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So x to the power of x minus 1, this would equal x to the power of x times x to the power of negative 1. And this is still equal to 1. So now, if I divide both sides by x to the power of negative 1, these two would cancel out, so I would get x to the power of x is equal to, well, 1 over x to the power of negative 1, this is equal to 1 over x to the power of negative 1 is the same thing as 1 over x to the power of 1. So this would be 1 over x. And 1 over x, well, this is simply equal to x. So 1 over x to the power of negative 1 is simply just x. So now we get x to the power of x is equal to x. And now x, the exponent for x is actually 1, right? So we have x to the power of x is equal to x to the power of 1. And as you can see here, we have the same bases for both of these, meaning if we have the same bases, our exponents are the same as well. So that means if we set our exponents equal to each other, we get x equals 1. So we get x equals 1, and this is a solution. However, as you can see here, remember this equation? X to the power of x minus 1 equals 1. Well, I'm actually going to rewrite this as x to the power of x minus 1 equals x to the power of 0. Because 1 here, 1 is the same thing as x to the power of 0. Now, we're going to do the same thing what we do here. We're going to set our exponents equal to each other. So we're going to set x minus 1 equals 0. And if we add 1 on both sides, we get x equals 1. So this is another way of doing it. And actually, we have our solution as x equals 1. However, there is actually another solution to this problem. X equals negative 1. This would also work as well, because if we plug this into our equation, for example, negative 1 to the power of negative 1 equals negative 1. Well, negative 1 to the power of negative 1 is simply 1 over negative 1. And this is equal to negative 1. And 1 over negative 1 is simply just negative 1. So negative 1 equals negative 1. So this is right. So x equals negative 1. This is also a solution to this equation.